Today I want to talk about relays. I got this little thing of relays here. Now that looks like a relay, but it's not. I'll talk about that in just a minute. These relays here are various different types. I'm going to talk a little bit about them. Some of them look more alike than they are. And this one here, okay, I guess that pretty well covers the ones we need to look at. All right, now this particular relay here is a horn relay, and the way that this particular relay here works, it basically, it only needs 3 terminals because of the way some of these older horn relays were wired up. We're used to seeing relays that will have 4 or 5 terminals, but for the purposes of making it simpler, these horn relays were just used with 3 terminals. I'm going to give you a little bit of wiring schematic. This is a standard ISO relay where you want to remember these relays so you can memorize the terminals. These are the coil, and that's the common. So it's coil, coil, common. And this one right here is the normally closed terminal, and that's the normally open terminal. So when you put power and ground here, then whatever's coming in here is going to go out here. Until you put power and ground in here, whatever's coming in here is going to go out there. Something on that it will load it, because if you don't load the relay, you can have continuity with a meter, but that doesn't mean that it'll carry current. This relay here is typically what's used on most General Motors cars, and the way that it's lined up, and the cool thing about some relays, they give you a little schematic and they got numbers on the around the posts and all that. But 85 and 86 are typically coded in the ISO world to be your coil, and 87 and 30. See, it's a 4-terminal relay, but there would be a 5th terminal there. It's even marked on that one. I don't know if you can see that or not on that film. But the cool thing about these is it doesn't matter if you flip them around and plug them in backwards, because if you notice, 30 and 87 are here and here, and then the coil 86 and 85 are here and here. So even if you flip it around, it still works. There's not any concern with polarity on a relay. Okay, now these relays here, that's a Toyota relay. It's a potted relay, and there are relays that look real similar to this. They have the same configuration on the terminals, but they're not potted like this one is. These relays have got peculiar qualities, like on this Nissan relay right here. The reason this particular relay was changed out because it was a blower relay on a Nissan Altima, and when she turned on her blower, she would have to have the blower on for something like 5 minutes before it would ever kick on and start blowing. And so we caught it doing that, and what we did was we took the rear window defrost relay and put it where this one was. And these relays here, you know, they can just die without warning or do crazy things that other relays usually won't do. This is a heavier version of this other relay, and the same rules apply to that. And once again, you've got a little schematic of the thing on there. If you look at how to test those. But make sure you always put a heavy enough load on the relay when you're testing it, so you'll know the relay will carry the current it needs to carry in the circuit. This is a peculiar relay that some of your GM cars have for the headlights, and these do fail, and occasionally we've had to replace some of those. I've got 2 of these in this little box here because I've had to replace them twice. Some fuse panels have got relays built on the inside of them too, and so you need to be careful about those, because in the schematic you may see that there's a relay there, but you're not given terminal numbers for it or anything, and the reason for that would be because of your the fact that it's built into the fuse panel. Of that, there's one of the Toyota trucks that we worked on as a 2012 model. It's got a whole bank of relays that's made together that can actually be pulled out of there and replaced as a group. Also, the Chrysler Crossfire was an 05 model that I worked on that had a bunch of relays all built together. Ford started doing that with their integrated relay control module back in the 90s, and it was a crazy thing to pack all those relays into that one kind of expensive box. Always like to be able to replace the relays separately. Now this is another kind of Toyota relay that goes on older ones, and one of the rule of thumbs that you can go with on relays is the 2 smaller terminals. If it's got 2 small terminals and 2 large terminals, the 2 large terminals are typically going to be the load carrying terminals, and the 2 smaller ones are going to be the coil. And once again, most typically relays are not what you would call polarity sensitive. They do have a little clamping resistor in there so that they don't send out a spike when you de-energize them. Now this looks like a relay, but it's not a relay. You might even notice it favors this, but it's bigger. And one of the reasons they made it bigger is they don't want you accidentally putting this where this goes. Now you could accidentally put that where this goes, but the simple fact is that is a flasher. That is a turn signal flasher, and it requires 2 powers coming in for it to work right. If either one of the powers coming into this flasher is not there, then you're not going to have any turn signal operation at all. And this same flasher is used for your hazard flashers and your turn signals. But you'll see this kind of flasher typically on the Ford, some of the Fords, and on some Jeeps and stuff. That relay right there, if you see one like that, you know, this is another flasher of that same ilk. This one here came off of a Chrysler, which would have been, you know, Chrysler would have made it on a Jeep and all that. There's another one of those potted relays. Now, some of these relays here, these relays like Ford used, which is like that one there, would basically, you might even look, and sometimes you'll see one that's got a little hole in here. Now, the thing about the relays that have a little hole, see, that one's got a little hole in it. Sometimes they got a little hole where you can get all the way into that thing, and ants will crawl in there, and for some reason they like to go right to the place where those little points are arcing. I don't know, I've seen ants on top of car batteries, you know, piling up across there to the point to where they actually short the battery out and eventually run it down. But ants love relays, and so but anyway, that was just a little rundown on different kinds of relays. Whenever you're working on a relay, this one's one I didn't mention. This is a Ford relay, like an early, you know, like a 90s Ford, like on some of your pickups and stuff like that, and they used these for years. And those 2 little small terminals in there, let me get those little small terminals in there are going to be your coil. And then these other terminals here, these terminals are numbered 1, 2, 3, 4, and 5. Now some of these relays will actually have a schematic on them, but most of the time they won't. And on that one right there, you know, it's really not very professional if you're making a video and you don't know which terminal is which. But the simple fact is, you can figure out which one of these is the same as this one. You've got a, you know, coil and a common, and I believe the common is the one that's with the with these little small terminals that go to the coil, and then these other ones are you're normally closed and you're normally open. You can figure it out. When I was teaching my son about relays, whenever he was a young boy, I got a relay that I desoldered off of a board in a electronic component, and what happened there was he had never seen a relay before, and those terminals weren't marked. But he had a little power supply that we built, a little 12-volt power supply with a transformer and a rectifier bridge. And I said, see what you can do with that. And after about 5 minutes, he said, I don't know what you call this, but I can tell you what it does. When you put power and ground to these two, it connects the other two together. I thought that was pretty interesting.